we are discussing linear equations in one variable, and we are in the last part of the topic, linear equations in one variable, where we are discussing about word problems. So some of the word problems will describe real world scenarios as well. So your job is to convert the statement that is given in English to a mathematical statement. And the second step is to solve it. Okay. So I guess in sheet number 11, there were a few questions which were left. So have you guys tried them? Have you guys tried them? Please let me know. By the way, I'm using two devices. Um, the one of the devices is shooting myself and the board, and it is facing, the camera is facing me, so I'm not seeing the chat that is coming to the coming to this device. Okay, so I have another device where I'm checking the chat. So either when you're chatting, either chat with everyone or message me on the other device. Okay, the second device. So have you guys tried this? Have you guys tried these questions? Yes. So I think we did problem number 1, right? We did 1, we did 2, we did 3. 3 was done. I think 4 is pending. Tell me, please type the question numbers that are pending. It's 4 is pending, right? Somebody please type the question number, the one that needs to be done. Hello. I guess we have done 1, 2, 3, right? Hello, am I audible? Am I audible? Yes. And what about question number 4? Did we do it in the class? Question number 4, did we do it in the class? Yeah. So that was not done in the class. So let's quickly do it. Did you guys try this question and get an answer? The question says the perimeter of a rectangle is 13 centimeter and its width is 2 and 3 by 4. Its length is, so perimeter is given and width is given. So you just have to find the length. So let us call, this is the unknown thing. Let's call this, say, L. Okay. Now your perimeter is 13. So 2 times length plus width. Width is 2 and 3 by 4 is going to be 13. So this is the equation we have. Right. So you just need to simplify this expression. You just need to simplify this expression. So there is a common equation we have. There is nothing difficult in this. So let's take 2 to the other side. So when you take 2 to the other side, we have L plus, and this mixed fraction can be written as an improper fraction, that is 11 divided by 4 is equal to 13 divided by 2. So here L is nothing but 13 by 2 minus 11 by 4. So this is 26 minus 11 divided by 4. So the answer will come out as 15 divided by 4. 15 divided by 4 is going to be the answer. I hope you've got this answer. 15 divided by 4. Please let me know whether you have received, you have got this as the answer. 15 divided by 4. 15 divided by 4 is yes. So next is question number 6. No, question number 5 you have already seen. I've marked it here. Now let's see question number 6. Question number 6 here. 7 more than twice what number equals 35? Okay, so just convert this statement in English to a mathematical statement. So how do we do that? 7 more than twice what number? So this what number is going to be x. Twice is 2 times. Okay, 7 more than means what? 7 plus equals 35. Simple, right? 7 more than twice what number equals 35. So 7 plus 2x is going to be 35. So bring 7 to the other side. We have 2x is equal to 35 minus 7, which is 28. And your x is going to be 14. You're able to see the board clearly, right? If you want me to switch to the old method, we can do that because that is going to give you a crisper, sharper screen. Okay, what do you prefer? Okay, no problem, no problem. Okay, now I think we have not done question number 7. Question number 7. 6 plus half a number equals 4 plus 1 by 1/3 of the same number. Again, 6 plus half a number, that is half of x, equals 4 plus 1/3 of the same number. So this is 6 plus x by 2 is equal to 4 plus x by 3. So bring this variables on one side, bring the numbers on the other side. So we have x by 2 minus x by 3 is equal to 4 minus 6. Cool? Yes. So this is x by 2 minus x by 3. This is going to be x into 1 by 2 minus 1 by 3, which is minus 2. 1 by 2 minus 1 by 3 is 1 by 6. Always remember this. Okay, always remember this. 1 by 2 minus 1 by 3. If you remove 1/3 from a half, you get 1 by 6. Okay, so x by 6 is minus 2. So you have your x as minus 12. Minus 12 is our answer. Minus 12 is our answer. Yes, minus 12 is the answer. Now I think question number 8 is done in the class. We have to do 9. That's all. In this sheet, we are left with question number 9. Then we'll move on to the next sheet. Okay. If you're stuck at some point, please do let me know. Okay. You may also take the mic and speak. No issues. So next is problem number 9. 3 pack of markers cost $9 less than 5 pack of markers. Which equation best represents this situation? So what do we have? 3 pack of markers cost $9 less than. So let's say if you represent the price of a pack of a marker as X, 3X is going to be $9 less than 5 pack. So it is going to be 5X minus 9. 5X minus 9. So just look at the option and tell me which option. You don't have to solve for this equation. You don't have to solve for this equation. Just tell me which one matches. Which one matches? You bring 9 to the other side. We have 3x plus 9 is equal to 5x, right? So that is the right answer. That's the right answer. So B is the right answer. So this sheet is done. Fine, right? Shall I move on to the next one? Please respond. Shall I move on to the next one? Yes. Cool. So we are going to sheet number 12. Let me see how many questions we have done in sheet number 12. Question number 1 is done. 2 is done. 3 is homework. 3 is homework. Let's see question number 3 now. The answer has 3 times as many $2 bills as he has $5 bills. If he has in all a sum of $77, how many $2 bill does he have? So you have to figure out what the unknown is. So the unknown quantity is the number of $2 bills. If you can call this X, you can call this X. Okay, but an easier approach is going to be C. If you call the number of $5 bills as X, this is number of $2 bill is going to be 3x. So that is an easier approach. Otherwise, you have to bring in fractions, right? So the number of $5 bills is going to be X, and the number of $2 bills is going to be 3x, right? So how much money does he have? He has 3x $2 bill, so that is 3x times $2 plus he has x number of $5 bills, so that is going to be x times $5, and altogether he has $77. So this is 6x plus 5x, that is going to be 77, and you have 11x is equal to 77. Your x is going to be 7. But 7 is not the answer. You have to find the number of $2 bills, which is not x, which is 3x. 3x, right? So your 3x is going to be 21. 3x is going to be 21. So he basically has 21 $2 bills and 7 $5 bills. So that is 21 times 2 and 7 times 5 is giving him $77, right? So that was a homework problem, and we had done question number 4 in class. Next is 5 is also done in the class. Let's do question number 6 now. Let's do question number 6. Let us do question number 6. Let us do question number 6. Yeah. Did you guys try these questions? 6, 7, 8, 9, 10 are homeworks. Did you guys try them? Please do let me know. Did you guys try them and got the answer? Yes. Okay, I'll quickly go through the questions. I'll quickly go through the questions. A garage has 17 cars and motorcycles. Altogether, there are 56 wheels. How many cars are there? So the individual number of cars and motorcycles is not given. So your question talks about finding the number of cars. Yes. How many cars are there? Let's call it X. How many vehicles are there altogether? There are 17. So the number of motorcycles is going to be 17 minus X. Okay. So 17 minus X is the number of. See, this is how you approach a word problem. Okay, you have to find uh, the. Although it's easy for you to see first of all, if you see this problem, you may want to think that there are two variables here. Like, of course, you can do in that way as well. You can say that the number of cars is going to be X, the number of motorcycles is going to be Y, and you can say that X plus Y is equal to 17. This is one equation. Okay. Now there are 56 wheels altogether. So motorcycle, 2 wheels each, and cars, 4 wheels each. So 2y plus 4x is equal to 56. You can model this problem in this manner as well. You understand what I'm saying? Instead of choosing one variable, you could have chosen two variables as well. Okay. Yes, understand. But then here the problem is again, it's time. We have time constraint. Okay, we have time constraint. Ultimately, you have to eliminate y. They have not asked about y. We have to find only x. So a better approach is start with one variable, just one variable. Remember, it is not always possible. Okay, it is not always possible to model a situation using just one variable only. Okay, we'll see such examples soon. Later on, we'll see those examples. But in this question could be modeled using two variables, but this question could be modeled using single variable only, which is going to be a faster approach. So it is important that uh, you choose the number of variables judiciously, so that you don't end up wasting time trying to eliminate one of the variables. You understand what I'm saying? Yes. So you could have written this way as well. You could have written this way as well, and could have gone for solving these two variables. This is a system of linear equations in two variables. But I choose not to go for this approach because it's pretty easy. Because if there are X cars, the number of motorcycles is simply 17 minus X. Okay. And the number of wheels is going to be, for cars, there are 4 wheels each. So 4 times X plus, for a motorcycle, it is going to be 2 wheels each. So this is 2 times 17 minus X. And altogether, there are 56 wheels. You just solve this equation. So we have 4x plus 34 and minus 2x is equal to 56. Combine the like terms, bring the numbers to the other side. So we have 4x minus 2x is equal to 2x, and we have 56 minus 34, which is going to be 22. And your x comes out as 11. Very neat. Okay. Cool. Of course, this could have been solved using two variables, but we choose not to do that approach because you are going to write one step extra and you will lose maybe say 10 or 20 seconds, which is a very valuable thing in an SAT. Okay. So let's go to the next question. We were on problem number 6. Yes. Next question is John is 20 years older than Steve. Again, you have to choose the variables judiciously. You may choose, see, the question talks about Steve's age and John's age. You may want to choose two variables, but it is going to cost you one step more and it is going to cost you maybe 20 or 30 seconds more. So let's not go for that approach. We'll go and choose just one variable, which is going to be Steve's age, because that is what is asked for. You're going to choose Steve's age as the unknown variable. So let's just call this as X. Okay. Now, John is 20 years older than Steve. So John's present age is going to be X plus 20. So make sense? So far, so good. You're going to choose Steve's present age as X. And now John's present age is going to be X plus 20. In 10 years from now, Steve's age will be half that of John's. In 10 years, Steve's age will be half that of John's. So these are typical word problems. Okay, age problems. Okay, always remember age problems are typical word problems that you would have seen this in schools. You can these kind of questions can appear in SAT as well. So uh, from after 10 years, their respective ages will be X plus 30. The older guy is going to be X plus 30 and the younger guy is going to be X plus 10. When? After 10 years. After 10 years. Right? And what is the situation then? In 10 years, Steve's age will be half that of the John. The bigger guy, the older guy will be double the age. Double the age. Or you can write otherwise. What? The younger guy the younger guy's age will be half that of the older guy. Right? You understand what this is, right? You understand this equation? The older guy will be twice as old as the younger guy, or the younger guy will be the younger guy's Steve's age will be half that of the older guy, John. Now we solve this equation. We have x plus 30 is equal to 2x plus 20. 2x plus 20. Bring x to the other side. We have 2x minus x. Bring 20 to this side. We have 30 minus 20. So your x is going to be 10. Your x is going to be 10. 10 is the answer. Let me check the answer. Yes, 10 is the answer. Cool. Let's go to next question. I hope you've got the answer. I, I hope you've got the answer for this question. Yes. Let's go to the next question. Okay. Again, this is another typical question. This is another typical question. Okay. It is tempting to choose two variables, but as far as possible, try to minimize the number of variables. As far as possible, try to minimize the number of variables. And when you have a ratio given, how do you approach this question? Listen carefully. Listen carefully. A father distributed his total wealth to his two sons. The elder son received 3 by 5 of the amount. So, how much did the younger son receive? How much did the younger son receive? One person has received 3 by 5, 3/5. Okay, 3/5. The one person has received 3/5. The other person would have received how much? What fraction? What fraction? Are you with me? Hello? Are you guys with me? Yeah. The other person would have received 2/5, right? Make sense? Prisha and Robin, the other person would have received 2/5. Yes? Yes, very good. Okay. So how many will okay, this should be how much wealth did the father have? How much wealth did the father have? So let's call this X. X. Okay. And this was distributed to two persons. One person received 3 by 5 of X. Of course, the other person received 2/5 of his wealth. How did you come up with the number 2 by 5? It's simply X minus 3 by 5 of X, which is going to be 1 minus 3 by 5 times X. 1 minus 3 by 5 is going to be 2 by 5. Of course, you may choose two variables X and Y. Okay, this is X, this is Y, and so that is going to be compulsory. Okay, so you might think at first glance you might think that there are two variables, but it's not always the case. Even if you can do it by taking two variables, always try to avoid it as much as possible. But there are situations where you will be forced to take two variables. Okay, we'll see such questions later on, right? And now this amount is given to be, wow, this is 30 grams, 30,000. This is 30,000, 30,000 US dollars. So 2/5 of X is going to be 30,000 US dollars. So your X is going to be, when 2 by 5 goes to the other side, it goes as 5 by 2. So this is going to be 5 by 2 into 30,000, 30K. Yes. Now you just need to simplify this. You just need to simplify this. So this is going to be, you cancel 2, this is going to be 15. 15. Now 5 into 15K is going to be, this is 5 times 15K. 5 times 15K is going to be 75K. 75K. 75K is going to be the answer. Got it? Yes. Let's go to the next question. Let's go to the next question. Mary's monthly magazine subscription costs $1.25 per issue. Ken's monthly subscription is $1.5 per issue, but he received his first two issues for free. Which equation can be used to find the number of months after which they will have paid the same amount? Just look at the options. Every option talks about an equation in terms of an unknown variable n, right? So let us say that the number of months after which they would have paid the same amount, let's choose this as n. At the end of n months, they would have paid the same amount. At the end of n months, they would have paid the same amount. At the end of n months, they would have paid the same amount, right? At the end of n months, they would have paid the same amount. Now let's take each case. This person pays $1.25 per issue. So she would have paid altogether a sum of n times 1.25, right? N times 1.25. On the other hand, the second person pays 1.5 per issue, but he received his first two issues for free. So for the cost of first 2 months, the cost for first 2 months will be 0. So that is going to be 2 times 0 plus. Okay. Altogether, we are assuming that there are n months. The first 2 months, his cost is 0. And for the remaining, how many months? There are altogether n months. The first 2 months are free, so that the cost is 0. Now there are n minus 2 remaining months. Okay. And this n minus 2 months he is paying $1.5 per month. Make sense? This equation makes sense? The equation makes sense. What does it say? There are n months altogether. There are n months in total. Okay. So one person has paid up a sum of n times 1.25. Why? Because she's paying $1.25 per month. There are n months, so n times 1.25. The second person has paid $0 in the first 2 months. So that is 2 times 0. Plus in the remaining n minus 2 months, he has paid $1.5. Now, why does there an equality? Why is there an equality? Because the question talks about the number of months after which they will have paid the same amount. See, that calls for an inequality. Equality. Got it? You understand why there is an equality, right? Why these two quantities are equated? This LHS talks about the money the first person who would have paid. RHS talks about the money the second person would have paid in n months. Okay, these are given to be equal. Make sense? Let me know. Please let me know if it makes sense. Please, please, please do let me know if it makes sense. Okay, that's cool. So the answer is going to be we have 1.25n is equal to n minus 2 times 1.5. This is 0. So this is the answer. C is the answer. C is our answer. C is our answer. Yes. Let's go to the next question. So the last one is a slightly different one. Okay, you should be very careful with this question. Okay, this is a very nice question. Very nice question. Okay. The present ages of Anne and Raj are in the ratio 4:5. 8 years from now, the ratio of their ages will be 5:6. What is Anne's present age? That's a very interesting question. That's a very interesting question. Of course, it's tempting to choose two ages as X and Y and proceed in that manner. But I'll tell you, it's not necessary. You can always do it in that way as well, but it's not necessary because, keeping less luggage, more comfort. Keep your number of variables as few as possible. Okay. Because, time is a very big constraint. So we don't have to bother about too many variables. So what I'm going to do is here I'm not going to choose anybody's age as the variable. I'm not going to choose this person's age or the other person's age as a variable. Okay. So here is the trick. If two numbers are given to be in a ratio of 4:5, the numbers can be chosen as 4x and 5x. The numbers can be chosen as 4x and 5x. See the trick? See the trick? You understand this? I didn't choose this person's as X or the other person's as X. I have taken the ratios given to be 4:5. So if somebody is telling you two numbers are in the ratio 4:5, the numbers can be taken as 4x and 5x. You understand this? Because if you take the ratio, x and x will go away and it's going to give you 4/5. You understand? If two numbers are given to be in the ratio of 4:5, the numbers can be taken as 4x and 5x. Yes or no? Is this confusing? Is this confusing? If there are two numbers, the ratio of which is given to be 4:5, the numbers can be chosen as 4x and 5x. Of course, x is an unknown quantity which we need to figure out. Is this confusing why it is why these can be chosen as 4x and 5x? What about others? What about others? I'll give you an example. See, suppose somebody is telling you that the two numbers are the ratio 4:5. One way to choose the numbers is say numbers may be 4 and 5 itself. The numbers may be 4 and 5 itself. Then the ratio is 4 is to 5. Then the ratio is 4 is to 5. 4 is to 5 means 4 by 5. Okay. 4 is to 5 means 4 by 5. And another possibility, say they could be 10, 8 and 10. 8 and 10. 8 and 10. In this case, the ratio is again same because the ratio is 8 by 10, which is 4 by 5. Another way to choose the numbers may be, say, 12 and 15. 12 and 15. In this case, the ratio of the numbers is 12 is to 15, which is again 4 by 5. So what did I just understand from this? It is, if it is given that the two numbers are in the ratio of 4 is to 5, the ratio of the two numbers is 4 by 5. It is not necessary that the numbers are 4 and 5. It simply means that the numbers will be multiples of, will be the first number will be a multiple of 4. Okay. And the second number will be the same multiple of 5. See here, the first number is 2 times 8. Here it is 2 times 10. In this case, it is 3 times 4. 3 times 4. And this is 3 times, 3 times 5. Okay. It simply means that if two numbers are given to be in the ratio of 4 is to 5, the numbers will be 4 times some number and 5 times the same number. 4 times some number and the second number will be 5 times the same number. So that the ratio of these two numbers will be always 4 is to 5. Yes. Cool. Yes. Okay. Yeah. So that is the trick I'm going to use. I'm going to choose the numbers as 4x and 5x. So the present age of Anne is going to be 4x now. Anne is 4x years old now. And Raj is going to be 5x. 8 years from now. 8 years from now. After 8 years, their respective ages will be 4x plus 8. And the second person's age will be 5x plus 8. I hope this is clear. Right? Initially, the ratio is 4x by 5x. So this is 4x by 5x, which is 4 by 5. This is 4 by 5. Yes. And 8 years from now, the ratio is going to become 5 by 6. So how does that translate into a mathematical equation? The ratio of these two numbers is going to be 5 by 6. So what do we have? We have 4x plus 8 divided by 5x plus 8 is going to be 5 is to 6. 5 by 6. Make sense? Got it? 4x plus 8 over 5x plus 8 is going to be the ratio of 5 and 6, which is 5 by 6. Yes, this step is clear? Okay. Remember, x does not represent anyone's age. Instead, 4x and 5x are the present ages of these two persons. So far, so good. Please let me know. Yes. Now you just need to solve this equation. So we have seen this kind of equation. This is not a linear equation, but we have already talked about equations which can be converted to a linear equation after cross multiplication. See, that is why we have done that in a very systematic manner. We have seen the regular linear equation. Then we have seen equations which can be converted to a linear equation. Okay. Now we are seeing word problems. Now this is not a linear equation. This is an equation which can be converted to a linear equation after cross multiplication. Just do a cross multiplication. Just do a cross multiplication. So we have 6 times 4x plus 8 equal to 5 times 5x plus 8. 6 times 4x plus 8 is equal to 5 times 5x plus 8. Yes. So 24x plus 32 is going to be 25x plus 40. Bring the unknown variables to one side. So we have 25x minus 24x, which is going to be x. We have, oh, something went wrong. 24, 48. Oh, I made a mistake here. It's not 32. I screwed up big time. See, this is 24x plus 6 into 8 is 48. That is equal to 25x plus 40. Right? Now bring 24x to the other side. So we have x, and here it is 48 minus 40, which is 8. Your x value is 8. Your x value is 8. So their ages are going to be 4x and 5x. So they are 32, and their ages are now 32 and 40. 32 and 40. See, their ages are 32 and 40. The present ages are 32 and 40. Look at the ratio. Look at the ratio. Look at the ratio. It's 32 by 40, which is going to be 4:5. Now, after 8 years, there will be 40 and 48 each. 40 and 48 respectively. 40 and 48. Now the ratio will be, you cancel off 8 on both numerator and denominator. It is going to be 5 by 6. 5 by 6. So our answer is right. X is equal to 8 is the right answer. But what is asked is Ant's present age, which is 32. 32 is the final answer. 32 is the final answer. Yes. Okay. Right. See, since this is very important, I've created one more sheet on word problems. Okay. Let's see one or two problems from that sheet. And in the next class, we will be moving on to solving inequalities. Okay. So far, we have been discussing about equations. Now we'll move on to inequalities. But before that, let's see some more problems, because this involves 2 steps. You have to actually understand one of the reasons why the SAT problems may look challenging is because of the way they phrase the questions. Okay, so it is important to understand how these people phrase the question. Instead of giving a simple mathematical equation, they could give a word problem where a real world scenario is described. Okay,